Hello, friends. Hydrocarbons. Hydrocarbons are those compounds which are made up of only two different elements, hydrogen and carbon. In these compounds, carbon atoms form the basic structure, and hydrogen atoms are attached to the carbon atoms. The simplest hydrocarbon is methane, in which 4 hydrogen atoms are bonded to a central carbon atom. Hydrocarbons can be further classified into 2 categories based on the presence or absence of multiple bonds between carbon atoms. In alkanes, only single bonds exist between carbon atoms, while in alkenes and alkynes, there is at least one carbon-carbon double or triple bond, respectively. Let's learn about these one by one. First, we will discuss alkanes. Alkanes are the simplest type of hydrocarbons, containing only single bonds between carbon atoms. These compounds have the general formula CnH2n plus 2, where N represents the number of carbon atoms in the molecule. For example, if N is 2, then the alkane has 2 carbon atoms and the molecule is ethane with the formula C2H6. Similarly, now let's move on to alkenes. Alkenes are unsaturated hydrocarbons that contain at least one carbon-carbon double bond. The general formula for alkenes is CnH2n, where N represents the number of carbon atoms. The simplest alkene is ethene with the molecular formula C2H4. In ethene, the carbon atoms are bonded to each other with a double bond, and each carbon atom is also bonded to 2 hydrogen atoms. The presence of the double bond makes alkenes more reactive than alkanes, as the pi electrons involved in the double bond can participate in various addition reactions. Addition reactions are characterized by the breaking of the carbon-carbon double bond and the addition of atoms or groups of atoms across the bond. One common addition reaction of alkenes is the reaction with hydrogen in the presence of a catalyst, such as platinum, palladium, or nickel. This reaction, known as hydrogenation, results in the formation of alkanes. For example, the hydrogenation of ethene produces ethane. Alkenes are also used as starting materials in the production of various chemicals and polymers. The most common example is the production of polyethylene from ethene, which is used to make plastic bags, bottles, and other plastic products. Other alkenes, such as propene and butene, are used to produce synthetic rubber, detergents, and other chemicals. Let's now talk about alkynes. Alkynes are also unsaturated hydrocarbons that contain at least one carbon-carbon triple bond. The general formula for alkynes is CnH2n-2, where N represents the number of carbon atoms. The simplest alkyne is ethyne with the molecular formula C2H2. In ethyne, the carbon atoms are bonded to each other with a triple bond, and each carbon atom is also bonded to one hydrogen atom. Similar to alkenes, alkynes are more reactive than alkanes due to the presence of the carbon-carbon triple bond. The triple bond in alkynes can undergo addition reactions, but they tend to be less reactive than alkenes due to the sp hybridization of the carbon atoms involved in the triple bond. Alkynes can undergo catalytic hydrogenation to produce alkanes, or they can undergo partial hydrogenation to produce alkenes. For example, the partial hydrogenation of ethyne produces ethene. Alkynes are used as starting materials in the production of various organic compounds such as acrylic fibers, plastics, and pharmaceuticals. Let's take a look at the IUPAC nomenclature of hydrocarbons. The International Union of Pure and Applied Chemistry, IUPAC, provides a systematic way to name organic compounds based on their structure. The IUPAC nomenclature for hydrocarbons follows some basic rules. First, identify the longest continuous carbon chain and determine the number of carbon atoms in this chain. This number serves as the root for the name. For example, if the longest carbon chain has 5 carbon atoms, the root name would be pentane. Next, identify any substituents, which are groups of atoms attached to the main carbon chain. Substituents are named using the appropriate prefix based on the number of carbon atoms in the group. For example, a substituent with 3 carbon atoms would be called propyl. If there are multiple substituents, they are listed in alphabetical order. To indicate the position of substituents on the main carbon chain, numbers are used. These numbers correspond to the carbon atoms in the chain, and the substituents are placed before the root name followed by the appropriate ending. For example, a hydrocarbon with a methyl group attached to the second carbon of a 5-carbon chain would be named 2-methylpentane. Hey friends, are you liking this video so far? If yes, then show your support by hitting the like button below the video and do share this video with your family and friends. Now let's get back to the topic. Cyclic hydrocarbons are hydrocarbons that contain rings of carbon atoms in their structure. There are several types of cyclic hydrocarbons. The simplest type is cycloalkanes, which are saturated hydrocarbons containing only single bonds between carbon atoms. Cycloalkanes have the general formula CnH2n, where N represents the number of carbon atoms in the ring. For example, the simplest cycloalkane is cyclopropane with the formula C3H6. Cycloalkanes are less reactive than their acyclic counterparts, alkanes, due to the angle strain and ring strain associated with the cyclic structure. The strained bonds in cycloalkanes can make them more susceptible to certain reactions such as ring-opening metathesis polymerization. Cyclic hydrocarbons also include aromatic compounds, which are cyclic hydrocarbons that contain one or more aromatic rings. Aromatic compounds have delocalized pi electrons over the ring, which contributes to their stability and unique chemical properties. Aromatic compounds have a distinctive aroma, hence the name aromatic. This is particularly noticeable when you smell gasoline or other petroleum products. However, it's important to note that not all hydrocarbons with aromatic rings are necessarily aromatic. For example, cyclohexene is not considered aromatic because it lacks the required degree of unsaturation and does not have a planar ring. Additionally, the term aromatic is often used to describe compounds that have a pleasant smell, but there are exceptions like phenol, which is an aromatic compound that has a rather unpleasant odor. Friends, hydrocarbons play a crucial role in various industries, such as the petroleum industry, where they are extracted and refined to produce fuels and other valuable products. They are also used in the chemical industry as feedstock for the production of various chemicals and materials. So that's it for today's video. If you find this video helpful, then do hit the like button below the video and do share this video with your family and friends. Also, if you have any doubts, then do comment down below. Thanks for watching. Goodbye.